Today we're solving problem 19 from the AMC 10A of 2022. Define L of n as the least common multiple of all the integers from 1 to n inclusive. There is a unique integer h such that 1 over 1 plus 1 over 2 plus 1 over 3, and you add all the values in between. This is h over L of 17. What is the remainder when h is divided by 17? So we want to know what h over 17 is. Now, let's see here. What are we given? Well, first, this is L of 17. We can find what that is. Like, we can just state all the values. L of 17. This is 1, contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, oh shoot, 14, 15, 16, and 17. There. Now, we can actually multiply L of 17 on both sides to get rid of this bottom. So, by doing that, we have h. h is equal to L of 17 over 1 plus L of 17 over 2 plus L of 17 over 3. And you add all the values in between, and you add the last value, L of 17 over 17. Yeah. So, well, now what we can realize is that we have all these numbers here. We want the greatest prime factors here. Well, here, let's just do this. L of 17. This is equal to, well, we have to multiply all the greatest, prime factors. 16 is, well, it's the greatest, let's just say, so it's the greatest power of 2 in this set, which is 2 to the power 4. And now we move on to the greatest power of 3, which is 9. So 3 squared times, Now there's just all these prime numbers left that we have to multiply that aren't factors. 17 times, what's next? 13 times 11 times 7 and times 5. So we have this here, L of 17, we have all the greatest numbers here. Now, in contrast to this problem, we want h over 17. So all these values here, they don't matter. Well, they don't really matter. We just want this. So we have to basically, so we can rewrite all this. I'm just going to. We have to divide by 17. Sure. So once we divide by 17, this 17 gets canceled off. So what we're left with here is 16 times 9 times 13 times 11 times 7 and times 5. There. What we have to do now is we have to take the mod of 17. Yeah. So now we can actually do this strategy of crossing out 16 and 17. We're left with negative 1 here times, well, yeah, let's just see this here first. 13 and 17. This is, again, negative 4. So it's like a rule. And then now you can just multiply these numbers out. So I'm going to go for 9 and 5, which is 45. And let's see, 7 and 11, which is 77. So these numbers, we just need to focus on 45 and 77. We know that, here, I'll draw a comma. So basically, let's start with 45. 17 times 2, this is 34, and 17, if you multiply 17 by 3, it will be greater than 45. 45 minus 34 is 11. So we have, now we have negative 1 times negative 4 times, well, that's 11. Now we have this 77 here to deal with. Well, once again, we have this mod of 17. 17 times what, 8? You know, not 8. But we need like a number that is less than 17, but like the most we can multiply. So we'll see 17 times 4. From here, we get 68. And we can't add any more values of 17 into 68, or else it will go above 77. So 77, you subtract 68 from 77, you get 9. You have to multiply these values out. This is equal to what? So this is 4 times 9, 36 times 11. Notice that 36, like, it can still be factored. So once again, earlier we know that earlier stated that 17 times 2 is 34. So we can subtract 34 from this again. So 36 is gone. So we subtract 34 from 36. We have 2 times 11. This is 22. So we take the mod of it. Well, this is 22. So we take mod of 17 because it's still there. And we're left with our answer, the remainder, which is 5.